Hello, I'll try to teach here how to find reciprocal of a linear function and then its characteristics, right? So when we do reciprocal of a linear function, it actually becomes a rational function. Why? Because linear function is like a polynomial, and when you do reciprocal, it becomes 1 over a polynomial, right? So your polynomial isn't the denominator. It becomes a rational function, correct? Let me start with an example. Let's say my example is equation of a line. Let's take one line. Let's say the line is y equals to half x minus 2. So if the line is half x minus 2, let's try to sketch the line here on the graph. Minus 2 is the y-intercept, so that is here, and the slope is half. That means rise of 1 and run of 2, 1, 2. So this is the next point, right? Similarly, we can go ahead, rise of 1, 1, 2. We get this point. Similarly, we can also go downwards, right? We can do minus 1, minus 2. So we can do minus 1 and then 1, 2. So we get these 2 points. A couple of points here. If we join these points, we get our line, correct? So let me draw a line for you first. So this is a very easy way of drawing a line. So y equals to mx plus b. B is the y-intercept, correct? So first mark your y-intercept and then slope, rise over run. So once you do that, just as I have shown you here, you get your line, correct? So this is your line, which is y equals to half x minus 2, correct? Now to find, so it has got y-intercept of minus 2 and x-intercept of 4, and it's rising with a slope of half, correct? Now I can write this line in decimals. Let me write this in decimal numbers. So half is 0.5. Let me write this as 0.5x minus 2. Just because I want to make a reciprocal and I don't really want to make it too complicated for you. Now what is reciprocal of this line y equals to half x minus 2? Reciprocal function, let's call that function as, let's say, gx. So we are trying to say that gx is 1 over y. Reciprocal means 1 over y, right? So that means 1 over this line. Equation of the line is 1 over 0.5x minus 2, correct? So 1 over 0.5x minus 2 is reciprocal of our given line, correct? Now this is a rational function. We have polynomial over polynomial, and in a rational function, denominator cannot be 0. So we have a restriction here, correct? Line had no restriction. Domain and range of the line was all real numbers. But this polynomial, when we do reciprocal of it, it becomes a rational function with a restriction. What is the restriction? That this denominator 0.5x minus 2 cannot be 0. So we write restriction here. That is 0.5x minus 2 is not equal to 0. Right? When you solve for it, we get x equals to 2 divided by 0.5. So 2 divided by 0.5 is 4, correct? So from here we say or x is not equal to 4, correct? You can check like this also. Half of 4 is 2 and 2 minus 2 makes it 0, okay? This is a better equation to use. So half of x minus 2 should not be 0, half of x should not be 2, and x should not be 4. So we get our restriction here. So this function g of x has a restriction, and that is that it cannot be 4. So if we have to sketch this function on our graph, first and most critical point is to eliminate 4 from our domain. How do we do so? We can do so by drawing a vertical asymptote at x equals to 4, right? So this is our point 4, right? This is 2, this is 4. So we'll draw a vertical asymptote here. Whenever you're trying to do reciprocal of a function, it is always a good practice to find restrictions first. correct? Now restrictions are the points which will make denominator 0. Now, so what is the equation of this line? The equation of this line is x equals to 4. This is at every point x is 4. Now our rational function cannot have x equals to 4 in its domain. So domain is all real numbers for g of x excluding 4. Do you understand that part? So that's a very, very critical thing which we have worked it out. Now, so now we know restriction of our function. Let's analyze this further. Can it have an x-intercept? Well, so if x is very large, so what value can give it 0? The x-intercept is, when will the function be 0? Correct? It could be 0 if the numerator is 0. But since numerator is 1, it can never be 0. Do you understand? So we look for x-intercept and we say x-intercept does not exist, right? Why? Because f of x can never be 0, right? Because since f of x can never be 0, right? It does not exist, right? What really happens? What really happens is that as x becomes larger and larger, you approach a value of 0. So what we say is, let's say you calculate the value when x is positive 1000. If x is positive 1000, then this number will be some number divided by half of 1000 is 500. 500 minus 2 is 498. And when you will divide 1 by 498, you get a positive number very close to 0. It approaches, but it is never 0. So we say when x approaches infinity, a very large number, y approaches 0. But from positive side, do you see that? But if I put a number which is minus 500 or minus 1000 or minus 2000, 10,000 for that matter, then minus, we get negative in the denominator, and when we divide by negative, we get a very small number. But this time the number is negative, maybe 0, close to 0, right? So when we approach minus infinity, then y approaches 0, but from negative side. What I'm trying to say is that when we are trying to approach infinity, positive side, then we are actually approaching this line to 0, right? And that's called horizontal asymptote. When we are trying to approach from the negative side, so we try to reach like this kind of, right? I'm drawing here because I've taken this minus 2 and it's approaching the line. So we call this as a horizontal asymptote. So that's the definition of horizontal asymptote. So what is the equation of horizontal asymptote? Equation of horizontal asymptote is x, y equals to 0, because y is approaching 0. So when x approaches positive infinity or negative infinity, if y approaches some value but it never reaches there, then we say a horizontal asymptote exists and the equation is the value which y is trying to approach. Here y is trying to approach 0 and therefore y equals to 0 is our horizontal asymptote. Okay, so we know we don't have x-intercepts, but let's see, do we have y-intercept? Okay, so for y-intercept, what do we do? For y-intercept, we have to plug x equals to 0, right? That means we have to find g of 0. So if I plug x equals to 0 here, I get 1 over minus 2. 1 over minus 2, which is minus half. So I do have a y-intercept, and the value of y-intercept is minus half. So that is my value of y-intercept. Correct? No. So we found vertical asymptote, horizontal asymptote, y-intercept, x-intercept we found. It is not there at all. Now let's look into domain of our reciprocal function. We are talking about g of x. Now what is the domain of this function? Domain, as we saw, is x belongs to real numbers, where x is not equal to what? Number 4, because 4 will make denominator as 0 and we have a vertical asymptote there. Correct? Now next is range. So what could be the range of this? Range is y belongs to real number, but what value we don't have? 0, right? So where y is not equal to 0, right? Y is approaching 0, we have a horizontal asymptote, but it is never 0, correct? So that is not there, correct? So that's how it is. Now, so we know all these characteristics of our function, correct? Now, we will try to sketch the function of g of x. Now, g of x, as you see, we have already got a couple of points, so this becomes a vertical asymptote. And in this quadrant, g of x is positive. Because here, if x is greater than 4, if I write x greater than 4, then this is positive, right? It is like greater than 4 means denominator will be more than 0, right? If I write 4 here, then it becomes 0. But 4.1 will give me 0.1 in the denominator, which is plus. Okay, and the reciprocal of 0.1 will be 1 over 0.1 will be 10, correct? Like that. Now, let's look into a graph. The reciprocal really means that the value, if it is 1, the reciprocal of 1 will be 1 over 1, correct? So, this point is 1, right? Y value is 1. So, reciprocal of 1 will be 1. This becomes an invariant point. This is common to our line, y equals to half x minus 2, as well as g of x. Now, if my value is 2, what is reciprocal of 2? What is 1 over 2? 1 over 2 is half. So, this is 1 and this is half. So, we get here. Do you see that? Likewise, if my value is, this value is how much? 3, right? 1 over 3 will be what? 1 over 3 will be, this is 1, this is half, 1 over 3. So as we go further ahead, we are approaching this line. Do you see that? That's what I meant by this arrow, saying that as we go higher and higher, the 1 over x or g of x function, this is g of x we're trying to draw in red, okay, approaches x-axis. Now this side, let us assume this is kind of half, then when it becomes double, like it becomes kind of, this is less than half, so it will be slightly less than 1. So we'll come to 1 over 2, it becomes slightly less than 2, right? So let's say here, correct? Now as you approach close to 0, it approaches a very high value, correct? So what I'm trying to say is, if you see the nature of the graph of g of x in this particular quadrant, you get an invariant point here where 1 over 1 is 1. And as you approach 0, that means a lesser and lesser value, you approach higher and higher in g of x, correct? And as you go higher and higher, x value is increased, g of x becomes lower and lower, right? So we get a graph here which is kind of approaching this, and here which is going up. So we can sketch this graph like this. Is that okay? So this looks like 1 over x shifted 4 units to your right, right? It makes sense. That is a transformation. We will see that also. Similarly on this side, we already have a y-intercept 2. So 2 reciprocal is half, correct? Similarly 3 reciprocal is 1 over 3. So we'll have these points which are approaching 0, and we have a point which is invariant. We can kind of have a graph here. Let me join from here, right? And this side, as we go, we will approach the line kind of like this, correct? So this graph which I have drawn is g of x. Does it make sense? So in this g of x, we see the domain is all real numbers except x equals to 4, and range is all real numbers except y equals to 0. Do you see that? And these points are called invariant points. Let me label them invariant. Let me write in different thing. Invariant means which don't vary. So this. Why are they invariant? Because their y value is 1, and when you do reverse of 1, you get 1, correct? So these are your 2 invariant points. Now, let's look into this graph from transformation point of view. So we have g of x. Let's say g of x is equals to 1 over, let me take 0.5 common, and then, oh, that's okay. So it becomes x minus, if you divide 2 by 0.5, you get 4. Correct? So basically, you see from here that it is 1 over x, which is shifted 4 units to the right. Correct? So this is shifted 4 units to the right. That's what it is. So normally 1 over x would have been here and shifted 4 units to the right. Correct? And if I factor it out, I can take it as half or 2 times this, right? So vertically stretched by a factor of 2. So instead of 1, we get 2, or if we just keep it here inside, we can say horizontally stretched by a factor of 2. Correct? Because half, when it is half, then it stretches by a factor of 2. Correct? So that is a kind of a stretch which we have. Okay? So from here, normally the point would have been at 1, 1, but you see that point 1 has moved to 2. So that is a horizontal stretch. Do you see that horizontal stretch? That's how it is. You should see it like this. Is that okay? So it is horizontally stretched by a factor of 2, right? And horizontally translated 4 units right. So if you draw 1 over x and then stretch it horizontally, that means move each point away from 0 by 2 times and then move it to minus 4, you will still get the same graph g of x which I have got here. Correct. Now, whenever you do reciprocal of a linear function, what you will always get, this is a very important thing to understand, always true. So what is always true for reciprocal of a linear function? We'll write if we have y equals to mx plus b, right? If I have y equals to mx plus b, then our reciprocal will be 1 over mx plus b. Is that okay? Correct. Now, for this function, what is going to be your x-intercept? X-intercept will never be there because we will have a horizontal asymptote. So for that, we say first thing, we have a horizontal asymptote, and the equation of horizontal asymptote is y equals to 0. It never has an x-intercept. As x approaches infinity, right, plus or minus infinity, y approaches 0, right? If you are approaching plus infinity, y approaches 0 from plus side. If you approach minus infinity, y approaches 0 from negative side, but it approaches 0. And therefore, this is a horizontal asymptote. How about vertical asymptote? Vertical asymptote is when denominator is 0. So that means mx plus b equals to 0, which implies what? What is x? Which implies x equals to minus b by m. Correct? B goes that side, then. So always vertical asymptote will be minus b by m. Do you understand? So we got 4 because minus of 2 is 2. Divide by 0.5 makes it 4. So that's your vertical asymptote. How about domain? Domain will be x belongs to real numbers, where x is not equal to the vertical asymptote, which is minus b by m. How about range? Range will be y belongs to real number such that y is not equal to 0. Correct? So these are your characteristics which will always be true. And now, can you tell me what is going to be the y-intercept? Y-intercept is the value when x is 0. That means x equals to 0. What is y? If you put y x equals to 0, you get 1 over b, right? See, b is your y-intercept of the line. So reciprocal of line, y-intercept should be 1 over b. Correct? So always, these are your points which will be true. And that's the characteristics of reciprocal of a linear function. Okay? I hope you remember this. It's very important to understand. Okay? Have a closer look at what I have given in the summary. Here it is. Okay? And then I will like you to try some questions on your own. Now, practice problems I could give here, right? So practice problems for you could be, you can find reciprocal of, oh, let me write the reciprocal function themselves, okay? But it is better to draw a line and then draw the reciprocal so that you understand the whole concept, okay? So let me write down the question like this. Draw the following line. And their reciprocal on same graph, just as I did, right? And then write characteristics of reciprocal function. Correct? Now let me give you a few equations which could help you to do. Let's say first let me write f of x equals to 2x minus 6. I'm trying to give you very easy, right? G of x equals to, I'll give same as I have given you earlier, because well, instead of minus I'll make it plus. Correct? And h of x equals to 5x. Correct? Try to do these questions on your own. So draw first the line, 3 different graphs, okay? One for fx, one for gx, and one for h of x. 3 different graphs, correct? And then their reciprocals. Let me just pull this sheet further so it's very clear to you. Have a good look at this question and then try it yourself. If you have any difficulties, put your comments or write it to me. I'll be glad to answer all your questions. I hope you understand. Thanks.